Hey, welcome everyone. Mark here at Blue Glow Electronics. This is only our second video down in our new workshop that we've been working on for quite a time now. And we're pretty excited to finally get to where we're getting closer to being done with working on the barn itself. And I can actually get back to working on some gear instead. Anyway, as you guys know, up here on the right here, I've been using this Variac for some period of time, and I absolutely love this Variac. The only challenge with it is really big. It's 19-inch rack mount plus another inch on each side, so you're at about 21 inches with the cabinet on it, and it just consumes a lot of bench space. So I think I've got another home for it on another part of the bench, but my main audio is set up here in this section. I really want something a little bit smaller. So was out wheeling and dealing at the Shelby Hamfest in 2022 and walked across this Sencore, they call it the AC Powerite, or its model number is the PR-57. And I picked it up fairly reasonably. I don't remember exactly what I paid, but it's a little rough. You know, on a 1 to 10, I would give it a 6-ish, something like that. The cabinets are pretty beat up, the metal cabinet. And it wasn't perfect on the faceplate either. So, but that opened up some avenues for me I had not thought about until I started trying to solve this problem of what do I put in place of this great big Variac to be much smaller and give me room for another piece of test equipment that I want to put up there. So let's take you on the journey we went through here. Alright, if any of you guys follow my Facebook page, Blue Glow Electronics, on there from time to time I post some random pictures and whatnot. About a week or two ago I posted a picture where I was using a Greenlee chassis punch, a 1-inch round chassis punch, to punch a hole in the back of this cabinet. The reason being is I want to come out of the back of this unit, come down the wall and mount into, as you can see right here, a power strip mounted to the leg of the unit. And so anything I plug into this power strip is then controlled by the Variac, instead of me having to plug into the front of the Variac non-stop and having this big cable go up across my bench. This is a similar setup to what I had going on up at the old house. I had 2 power strips there, and I'll have another one on a different leg here of the bench that's 120 always on, and then this one that is controlled by the Variac. So all I really wanted to do was come off of the front power panel switch, and I soldered some wires up and brought it back out to the back of the unit. That way I can plug a plug in it. I can work the front and never have to deal with plugging anything on the front of a Variac. Not my favorite place to plug things in. So anyway, got that soldered up, but what happened was, let me show you. As I started soldering on this plug on the front, it just came all to pieces. It had just slap worn out, had seen better days, and I thought, you know, I'm really not going to use that plug on the front, and cosmetically this is not the nicest unit on earth, so I found this little digital multimeter that does a couple things, and I just came in here and kind of cut out, used a Dremel, and instead of a little bitty hole here I made a little bit bigger hole. Normally I would not go hacking up a nice piece of test gear, but this one's not in, like I said, the best shape anyway. The cabinets, you know, you'll see those later, pretty beat up. But anyway, I mounted this little unit in it. Let's show you what it looks like. All right, what we've done here is I've plugged in my oscilloscope up there into this unit just to have it draw a little bit of current. And if we notice, what I've got now on the front of this unit is a nice little readout that tells me 118.7 volts, and that's across the outputs of the Variac. I'm pulling 0.88 amps, 77.8 watts, okay, at 59.9 hertz, and at a 0.74% power factor there, as you can see. And this is a kilowatt hour, so if you leave this on over time, this thing kind of counts up. Not relative to us today. Alright, but I noticed something's a little odd. So this is a voltmeter directly, AC voltmeter directly across the output of the Variac. Keep in mind, these are nice little units. They have 2 things built into them. On the front end, you have an isolation transformer so that you're completely isolated from the AC mains. Then you have this little Variac here that lets you vary the voltage all the way from 0 up to about 140 volts, so you can actually pick up some voltage in the transformer winding here. But if you'll notice here, we're at 118.9, we're at 119, so this thing's, you can see it's bouncing around 118.9. We're pretty accurate here on this, close enough for what we need here. But as I come over here to the analog meter that originally came on this unit, if you'll notice, it is reading around, what, about 112 volts. So not 118.9 or 119, 112. And if I look at the line input, so you switch this button, it shows you what's feeding into the Variac, right? It shows it sitting here at around 115 volts. Well, if we peek over here to the side and maybe zoom in a little bit, you can see I use this little AC power monitor back here that's always on. Constantly I know where my line voltage is sitting at, and I know it's at about 120 volts right now. So something's not right here, okay? And what it comes down to is the meter here is not calibrated in line with these units. Well, you would think that's simple enough. Let's go take a look at the instructions, service manual for this, and we'll figure out how to calibrate this unit. Alright, one of the beauties of Sencore gear is they always had great manuals, and save you guys from dragging through this. Page 26 here gives you the calibration procedures, okay? And it's telling you that you want a little bit of a load hooked up to this so you can actually get some current readings or whatnot. I'm using an oscilloscope. They use a dim bulb here. Anyway, it walks you down through here, tells you what buttons to push and whatnot. And with the PR-57 on, you can adjust the voltage calibration R6 on the board until the meter reads what it tells you to read, so on and so forth. So let's go back over to the bench and do this procedure. Okay, there's really 4 calibration settings inside of this unit. The first one here, if you'll read it on the board, it says 1.5 amp calibration. So there's a current setting on this, and there's 2 ranges. There's a 4 amp range and a 1.5. So this would be for aligning the current. I haven't even made it that far. I got to get the voltage right. And then this little wire wound kind of resistor slash inductor. I had to look at the schematic a little closer to know what role it's actually playing. I think it's probably playing the role of a resistor. And then right here in the back, you have a setting for the leakage calibration. This thing has a leakage probe you can plug into it. And then last but not least, right here is the voltage calibration. So I'm going to insert a screwdriver and adjust this one, and you guys can watch on the front at the same time. You'll just have to trust me that that's the one I'm turning. So here we are, like I said, 119.3, 119.3, and let's insert here into this. We're up at 110, okay? Well, as I turn this unit, it comes down, but I can't get it up beyond 114, and yet we're at 119. So I'm all the way at the end of this potentiometer, and I cannot adjust it any more than that. And I'm thinking, maybe now I know why I got this unit for so cheap. It has some issues in it. Alright, so we come over here to this beautifully well laid out schematic that Sencore provided in the back of their operation and service manual. And I start looking at it, and one of the things I found right out of the gate here was this 4 amp calibration. Remember earlier I was saying, could be a wire wound resistor, could be an inductor. Anyway, I was right on my estimation. It is playing the role of a resistor, and that one little wire on it was a tap, and you kind of move the tap to adjust this one. But then I got over to the metering circuit over here, and I was looking at it, and I see here that down at the bottom we've got the meter itself, and it's full scale 100 microamps, resistance of the coil winding in it 1900 ohms, and I noticed right across it is a 10 microfarad capacitor. And I'm thinking to myself, well, the way this thing works is a current goes through here, and depending upon how much, it will determine how much deflection of the meter you have. And if for whatever reason this 10 microfarad capacitor was leaky, Well, instead of all of your current making it down and through the meter, some of it would get shunted here across this capacitor, and you would not get full scale deflection on your meter. So this unit's probably 40 plus years old. I thought the first thing I need to do, and by the way, I think this is the only electrolytic capacitor in it, so I thought I should probably replace this electrolytic capacitor, which I'm going to do. However, I got to studying a little more here, and I see some diodes in this unit, okay? The first ones I see down here, these are some LED diodes that poke through the back of the meter and tell you which setting you're on, basically, okay? So just LEDs. And then I notice all these diodes up here. We've got a 15 volt Zener diode and another 15 volt Zener diode. And if you guys have spent any time around Zener diodes, you know they're diodes encased in a little glass envelope, typically with a little bit of red on them, kind of a burgundy-ish red color, and then they'll have a black stripe on one end to indicate the anode on your diode, right? I'm thinking, okay, those are kind of clear resistors. Then I see this 1N4148, super common small signal diode there again, in a glass envelope with a little bit of burgundy and a stripe on one end. And then I see some 1N695s, which are a little bit larger than the 1N4148, but still a small signal diode in a glass case. And all four of these are 1N695s. So I bring up a little picture here of what's inside this unit. And I see some diodes here in and around the metering circuit. And none of these are small little glass envelope diodes. These are larger 1N4007 diodes that someone has put into this unit. Here's the gotcha, okay? And you can tell these have been replaced just by how wonky they're kind of all sitting around in here. Here comes the problem. These are silicone diodes. These 1N695s, they are germanium diodes, okay? The voltage drop across a germanium diode, typically about 0.3 volts. The voltage drop across a silicone diode, 0.7 volts. So what would happen here is you would lose voltage, ultimately feeding this meter here, that would ultimately then not give it full scale. So we're going to do two things here. We're going to go replace these with some 1N695s, and we're going to replace this little 10 microfarad capacitor. And while I've got this board out, I might as well check the resistors in it just to make sure that they're all within spec as well. And hopefully that'll get us back to where we need to be. Okay, as you can see here, two little glass diodes. These are the Zener diodes in the circuit, right? If we swing over a little bit, you can see right here the little 4 LEDs that plug into the back of the meter. And then you can see here someone just replaced these with standard silicone diodes. I assume that was some kind of rectifier circuit and they just dropped those in there, but that is not the case. So we're going to replace this one capacitor here and these 4 resistors. By the way, a bag of 1N695s. It is a little clear diode, as you can see right there. As you can see now, we've got the diode replaced and the 1N695s down in here put back in. Let's power it up and see if we get any better results. Okay, we put the unit back in and powered it back up after replacing the one capacitor and the germanium diodes. My assumption was that the 0.7 forward voltage drop on the silicone diodes versus the 0.3 volts here, about 0.4 volts, was really what was keeping my needle deflection from being able to go far enough over and get this thing calibrated in here. But that was not the case. Still can't, it goes further over, can't get it far enough to get it in range though. So what I've been doing since then is I've lifted off, I've been using a solder sucker, and I've lifted off the single leg on all of these components resistors, whatnot along the way, just double checking to see if anything was way out of spec. Well, right here is what they have listed as R07. It's a 1.2 mega ohm resistor, and high resistance resistors are known for drifting, even more so than low values, especially when they're carbon comp like this. And this one's up to 1.372 mega ohm. And let's go take a look over here at the schematic. Okay, if we come over here on our schematic and we look at the voltage adjust on this unit, the one we're playing around with, it's right here in this little blue box. And if we'll notice, what we're adjusting is this 500K potentiometer, who is directly in series with this 1.2. So you can kind of think of this as 1.7 meg, and we're adjusting the last 500 meg of this. So if this thing here is out by, say, 200K or whatnot, it certainly could have an effect. So let's get this 1.2 meg resistor that's reading really high swapped out with something more appropriate around 1.2 meg. Okay, let's power it up now and see what we get here. All right, we're at 109 volts here. Over here we're showing a little over 100 volts. But look, you see this? We're now able to adjust beyond the 109 volts. So I can bring this back just short of 110, about right there, to 109 volts. And we've got the voltage setting calibrated. So that one little resistor, probably in combination with the drop on the diodes, is got us back into calibration on this scale. Now we'll go through and calibrate the other elements. As in life, nothing is simple. So then I went to this little potentiometer, which, by the way, did look like this, and tried to adjust the 1.5 amp current setting. There again, couldn't get it in range. Guess what? This unit itself turned out to be the problem. It had gone out of whack. It would not go any lower. So on one end, it should, when you swing a potentiometer like this, should go all the way to 10K on one end, and theoretically all the way down to zero resistance on the other one. This one would go to 9.4K on one end and around 685 ohms on the other end. Could not get it down to zero. So I ended up replacing it, and I did not have an exact same fit, so I had to do just a slight bit of modification, but I ended up replacing it here with one. And as you can see, it's got a knob on it, and I used a screwdriver and adjust it. And we were able to bring the 1.5 amp current setting back in. By the way, once you do that, you do need to go back and readjust the voltage line calibration, which we did. All right. Then, fortunately, fingers crossed here, the 4 amp, it was actually in spec. So did not have to calibrate it at all. If you would have, it would have been a matter of moving this little wiper arm that's soldered on along the various points on that resistor. So just like doing a wiper, right? By the way, these two knobs keep falling off and won't stay on. And since the whole panel comes in and out with the knobs on it, all I did here was a little bit of 5-minute epoxy. I'm just going to put a dab on the inside of these things, just enough here. And I am going to insert these back on, and I guarantee you they will glue on there good. Okay, as you can see here now, I've got a little over 1.1 amps here. I've got this thing down here, 1.12 amps. If I go to output here, I'm at a little 92 volts roughly. Here's what I will tell you that I've learned along the way in adjusting and playing with this thing. This unit right down here is more accurate than this unit. Here's how I know that. One of the steps I did, I took this blue line and I unsoldered it, and then I put in line with it my digital multimeter set on 10 amps of current right here. And then I put an alligator clip on that and then one on the blue wire. so that I was actually reading the current flowing out to that little socket on the back. And my digital multimeter and this unit were spot on no matter where in the scale I was at. What I'm finding is this thing is not 100% linear. You get down in some of the lower ranges, you're off by a few. You get way up here, you're off by a few. So you kind of have to pick a sweet spot and calibrate it based on that. The voltage is a little more linear than the current setting on this one for whatever reason. But this little thing right here and my multimeter are just about spot on all along the way. So if I had it to do over again, I mean, this thing was $19 off of Amazon, shipped to my door next day kind of thing. If I had it to do over again, I would have probably looked for a bigger version of this. I would have put it in right here, and I'd have probably gotten rid of all these buttons, and it would have been as simple as turn this thing on and adjust this right here. This is a neat little switch. If you notice, a magnetic circuit. So if this thing has any type of short, it will sense it, and it will kick this circuit off on its own. So it's almost like a little circuit breaker as well as a switch at the same time. But I'm extremely happy with how this turned out. Let me get the case on it and I'll show you that, and then we're going to put it up on the bench. Okay, we've got the cover back on it. You can see 109.98, 110. From a cosmetic standpoint, as I mentioned, got a pretty ugly sticker thing on top of it, and then the sides here, just a little bit. It's got some vinyl coming off of it. It's not horrible, but you know, 1 to 10, it would be a 7 at best. There's a little bit of chipping here of the face plate, but all in all, pretty happy with how this unit turns out. I think we're going to put it up on the bench and use it because I love this little meter and all it's got going on down here. And this is good to watch too. You can watch for change easier here than you can here, and take up a whole lot less space than that unit up there is currently consuming on the bench. Anyway, thanks for watching, guys. Glad to be back to doing a little bit of videos, even though I'm working on my own gear to get it up on the shelves and whatnot. Hopefully we'll get this barn done here between now and end of year, and I can get back to, instead of working on the barn, I can work in the barn on making more of these videos. Hope everybody's doing well, and see you guys again soon. All right, we're still in the middle of moving things from the house shop down here and bringing some stuff out of storage. As I make each move, I'm testing each piece of gear out, cleaning it. I've been replacing fans if they're noisy. I'm trying to get the bench right as we roll in. But look, this new little Variac over here on the left-hand side that we've just installed, if you compare it now to the space, it let me now put my B&K signal generator along with a Keithley THD meter right there on top. It also freed up enough space here for me to put a oscilloscope in and my signal tracer down here on the other end. So super happy with all that. Look how I've got this set up now. On the left-hand side here, I have a power strip that is live 120 all the time. Okay, whatever I plug into it is hot and on. The right-hand side over here, though, if you notice, it's labeled Variac on it. And up and down it, all of those outlets are now, because that unit goes up, plugs into the back of the Sencore unit. So as I turn the Sencore unit on, go up and down, I can have multiple pieces of equipment in the Variac all at once. And I'm not having to plug in above my head on the bench. I'm plugging in down below. Much more convenient and ergonomic to work with. Just thought I'd show you guys that. We will see you guys again soon. Thanks, everybody.